Hi everyone. I wanted to make sure that we have one more summary of what we are looking for and how we can solve rational equations. Some of the key points that we need to cover are making sure that we understand how to find the excluded values or define the domain. That would be for the value of x, making sure that we understand what x can and cannot equal. How to find the least common denominator, also known as the LCM, the least common multiple for the denominator, and using that denominator by distributing the LCM or the LCD through the entire equation. And then, of course, checking for extraneous solutions. So let's take a look and see what we are going to work with. Here's our first equation. We have 2 over the quantity x squared plus 5x plus 6 plus 2 over the quantity x plus 3 is equal to x plus 5 over the quantity x squared plus 5x plus 6. First thing we want to do is find the excluded values or identify the domain of x. And so the way we're going to do that is we're going to factor all of the denominators, right? So these denominators need to be factored. The first denominator can be factored into the two binomials x plus 3 times x plus 2. The second denominator, well, it's already factored, x plus 3. And then, of course, the third denominator is the same as the first, so its factors are x plus 3 and x plus 2. We're going to set each of these factors, each of the unique factors, equal to 0. Since we really only have two unique factors, x plus 3 is in all three of these denominators, and then x plus 2 is in two of the denominators. There are only two different factors to work with. So x plus 3 is going to be set equal or not equal to 0, and x plus 2 is going to be set to not equal to 0. That means that x cannot equal 3 and x cannot equal negative 2, and we're going to have to remember that later on. So the domain for x can equal all real numbers except negative 3 and negative 2. All right, so we're going to use the denominator factors to identify the least common denominator, which is also the LCM or the least common multiple. So the least common denominator is all of the denominator factors that you can identify, the unique denominator factors that you can identify in the denominator. So that means that x plus 3 and x plus 2. And I don't see any other factors here, so the entire LCD is x plus 3 times x plus 2. So we're going to use this LCM LCD to distribute through the entire equation, in order to eliminate or cancel out all of these denominators from the equation. So we're going to put brackets around our equation. What we've got here are, again, all of the same three terms with the factored denominators. Put brackets around it. This is the set of brackets that I put around my original equation. And what I have out here is the LCD, the two factors of the LCD. And the reason why I have them here is I'm going to show that I'm going to distribute those. So it gets distributed into the numerator of all three terms. It gets distributed into the numerator of all three terms. So for the first term, it got distributed into the first numerator times 2, right? Because the first numerator, you can see up here, it has 2. And the LCD got distributed into the second numerator, again, times 2, because that's what we had in the original numerator. And then the LCD got distributed into the third numerator times x plus 5, because that's what we have in the original numerator. All right, now it's time to cancel. The reason why we're placing those there or distributing those into the numerator is to cancel out the denominators. So you'll see that there's lots of common factors to cancel out here that will essentially eliminate every single one of those denominators. The x plus 3's cancel here, x plus 2's, the x plus 3's cancel here, the x plus 3's, and the x plus 2's. So that leaves us with an equation that is just 2 plus 2 is equal to x plus 5. So that's what we're going to end up solving. I'm sorry, it's not 2 plus 2. It's 2 plus x plus 2 times 2 equals x plus 5. And you can see that what we have here is an equation that's much more easily solved. So you're going to distribute, combine like terms, get x isolated, and in the end, x will equal -1. So x equals -1, that's our found solution. We're going to take a look again at the excluded values, which are -2 and -3. Since x is equal to -1, and that is not the same as any of the numbers in the excluded values, that means we do not have any extraneous solutions.